Hello guys, welcome to my channels. Study of. I am your Sankar sir.
टेंशन नहीं लेने का अपन है ना
Today I will discuss about the thermodynamics. So before in these chapters, part 1, part 2, part 3, part 4, I have already discussed. So go through that chapters and go through the numerical problems also. I have also sent some numerical problems and I also discussed today also. And please don't forget to subscribe my channels and yours any queries, so inform me. I'll be here and your support, I require your supports and your supports makes me happy. So let's start.
अगर तुम लोग नए हो तो सब्सक्राइब करो, वो जो लाल वाला बटन है उसके साथ स्कैम करो या फिर महफिल जमाओ, मुझे नहीं पता, बस क्लिक हो जाना चाहिए।
First law of thermodynamics. First law of thermodynamics. Before this, in the previous sections and part 4, I have discussed the internal energy and their change of internal energy also and reversible, irreversible reactions. So in that case, today I will also little bit discussion about calculation of delta U, that is the internal energy change, how to calculate in case of ideal gas. So what we know, the delta U equals to NCV delta T. NCV delta T we know out here. If you derivative say then du equals to d NCV delta T. Okay. So in case of this equation delta U N CV delta T. Okay. N number of moles, N equals to number of moles, clear. CV, what is the CV? Molar specific heat capacity. I will discuss in the later section. Molar specific heat capacity at constant volume and delta T equals to change in temperature. So you write out here N equals to number of moles, CV equals to I have told you, and delta T change equals change of temperature, change in temperature. And CV, what CV? Molar specific heat capacity at constant volume. Okay. In case to find out delta U and CV delta T, so number of moles will be given, and if you find out the value of CV, how to find out? It is very important. So if you have to find out the value of CV, then N will be given there, delta T will be given. The CV, how to find out? One formula to find out the CV. CV equals to, a formula is there. I will also discuss in the later sections. Now F by 2R. What is F by 2R? The value, you have to find out the value of CV, F by 2R. What is F? F is the degree of freedom. Degree of freedom, that is the moment of the motion, rotatory motion, tangential motions of the particles. In that case, F will be considered. And value of F will be vary in case of monoatomic gas, diatomic gas, polyatomic gas. In case of monoatomic gas, F will be 3 for monoatomic, and in case of diatomic, F will be 5, and in case of polyatomic, F will be 6. Monoatomic gas means hydrogen, helium, neon. Diatomic means oxygen, nitrogen, okay, and polyatomic means O3, SO3, all these things. So in this case, to find the value of F will be given. So we have to put the value of F, and R, value of R will be, in case of Joule, calorie per mole Kelvin in Kelvin, calorie per mole Kelvin. In case of 2, value of R 2 calorie. In case of calorie, the value of R approx 2 calorie per mole Kelvin. And in case of Joule, if you find out the value of Joule, 8.314, okay, Joule per mole Kelvin. Okay, so you have to write out there 8.3145. Put this value, and in case of monoatomic, this, in case of diatomic, this, F, in case of polyatomic, F is this. So CV will be out here, and put the value out there. You will find out the delta U, that is the internal change of internal energy. Clear? We also discuss in the details in the next sessions. That is Boltzmann's constant. You have to degree of freedom, that is number of independent terms in the expansion of kinetic energy, that is the half m I omega square. There are so things. So I will not discuss this time. I will discuss later. Just this is very important. Some sums will come. So in that case, you have to find out internal change of internal energy, calculation of change of internal energy by applying this formula. Now come the first law of thermodynamics. Okay. First law of thermodynamics. What is the first law? First law of thermodynamics means you should have to know the law of conservation of energy. Okay. Law of conservation of energy you have heard. What is the law of conservation? That is the first law of. That is, energy can neither be created nor destroyed if that it may be changed from one form to another. Okay, and total energy of the universe is always constant during any physical or chemical change. Total energy of the universe always constant during any physical or chemical change. So mathematical expressions. So I am not writing the law. So mathematical expression of this mathematical expression. What will be the mathematical expression of this? Okay. So suppose a system having initial internal energy, after applying the Q heat, its internal energy will increase. That is internal energy, whatever U1, it will be U1 plus Q, and W work is done on the system. Okay, that is the system out there. Its internal energy, suppose U, internal energy, okay, U1, after applying heat or energy Q, it will be U1 plus Q, and the work done on the system, it will be W. So initial energy of the system, internal energy of the system, initial internal energy of the system, U1, clear? And after applying, suppose after I am applying the heat Q, so its internal energy will increase U1 plus Q, and then having done the work W on the system, work done, that is W on the system plus, so the final internal energy, it will be U1 plus U plus W, okay, this is the final. So let it will be U2, final. So from U1 to U2, okay, initial U1 and final U2. So change of energy, internal energy, delta U equals to what? What do you know? And here we can write U2 equals to, what? U1 plus Q plus W. From here we can write U2 minus U1 equals to Q plus W. Clear? U2 minus U1. What is U2 minus U1? Delta U equals to Q plus W. Delta U what? Change of internal energy. This is the first law of this heat change. So what is the heat? Heat absorbed by the system and work done on the system. Positive. Heat absorbed by the system, positive. That's why change of internal energy, delta U equals to Q plus W. This is the first law of thermodynamics, and it is the mathematical expressions. Okay. The mathematical expression of this thermodynamic, delta U equals to Q plus W. Here heat is absorbed and W work done on the system. Clear?
A few moments later.
So, thermodynamics, here first law. This is just the law of conservation of energy, but so very important thing. Oh, first law. Okay, now, hold.
For isothermal reversible or irreversible expansion of ideal gas. Isothermal, reversible or irreversible expansion of ideal gas. So what do you do in case of isothermal? What do you know? Delta U equals to 0. We know delta U 0. Okay. That is, why delta U 0? In this case, Q equals to minus W. Delta U, that means Q equals to minus W. Yeah, Q minus W. Here delta U equals to 0. For irreversible, now for irreversible. For irreversible expansion. So expansion, what we know, W equals to minus P external delta V, minus P external delta V, we know. For irreversible expansion of gas, isothermal irreversible expansion of, we have discussed in the earlier classes, W equals to minus P external delta V. In this case, what? We have to find out the value, delta V what? So in this Q equals to what? Minus W. Okay, so in this case, Q equals to minus W, okay, minus W, that means W equals to what? So both side, Q equals to minus W, so P external, that minus will be plus P external delta V, P external delta V, minus B, P external delta V, clear? In this case, W equals to minus Q, so W equals to minus Q, Q equals to minus W, equals to P minus plus P external delta V, हो गया? For reversible, in case of a reversible, what we got? For reversible, what we got? W equals to what? W equals to what? W equals to minus 2, we know, minus 2.303 nRT, 303, okay, nRT log V2 by V1, we know it, okay, we know V2 by V1, W equals to minus 2.303 nRT log V2 by V1, W equals to Q equals to minus W, clear? Again, Q equals to minus W, so in this case Q equals to minus W, the minus W means it will be plus, just it will be plus, then it will be plus 2.303 nRT log V2 by V1, okay. So for reversible and irreversible expansion of ideal gases, we can find out the work done and heat produced, okay. Next, so in case of first law of thermodynamics, we have to numerical expansion, numerical problem. I am now discussing one or two numerical problems out there. So what is the numerical problem out there? Suppose 200 joule, numerical problem 1, suppose 200 joule of work done. So 200 joule of work, 200 joule of work done on system, and 140 joule, yes, 140 joule, sum is 200 joule work done on system, work done on a system. हम शॉर्ट में लिख रहे हैं, 140 joule of heat, एतो joule of heat absorbed by the system, heat absorbed by the system. तो what is by absorb or it is given out, it may give in absorb or may be given out, दोनों कंडीशन हो सकता है, ए भी 200 joule work done on the system. In case of that, 140 joule of heat given out by the system or absorbed by the system. Given out, one is absorbed. So in that case, find out, in this case, find delta U. Yes, find delta U. So in second case, so for right, what is the condition? What you know here, W work done, W equals to plus or minus work done on the system, so it will be plus, work done on the system, it will be plus, so W equal to plus 20. Here if 140 joule heat given out और absorb होगा तो प्लस होगा, given out होगा माइनस होगा, therefore heat is given out, Q equals to minus 140 joule. In case of second case, given out, that is 140 joule is given out. So in that case, delta U, what we have done in the thermodynamic first law, E equals to Q plus W. Out, find the value 200 plus minus 140 joule equals to 200 minus 140 joule equals to 60 joule. Is the answer? Okay, is the answer clear? Clear? Okay. Now next example. Clear? Copy कर लिया. Okay. Next. In case of absorb, it will be added and positive sign. Next, and I will go further. Next, a gas absorb 125 joule of heat. Suppose a gas absorb 125 joule of heat. Okay, 125 joule of heat. A gas, see, in a system, a gas is absorbed 125 joule of heat. Clear? And in that case, if it is absorbed, in that case, and it will expand. After absorbing, it expands. After applying the pressure, and it expands, exerting a pressure, that is external pressure, P external, that is exerting pressure of suppose pressure of 1.2 atmosphere atm, and this pressure applied external pressure and it expand, absorbing at the heat of joule, applying this pressure, it expand on expansion. So expansion what? From expansion take place from say 1.5 to कितना होगा 1.5 liter to okay expand तो 0.5 liter to 1.5 कर दो 0.5 to 1 for your better calculation 1.0 liter. Okay, so what is the problem? A gas absorbs 125 joule of heat and it expands, and after applying external pressure of 1.2 atmosphere, and it expands from 0.5 liter to 1.0 liter. So in that case, find what? Internal energy. Okay, so delta U you have to find out. Find delta U. Clear? So find how to find. That is initial volume, final volume, V2 minus V1 is given, but out here absorb heat also given, and external pressure 1.2 atmosphere. So what is the formula out here? What will be the formula out here? You should have to apply the formula. What is the formula out here? See, I will do, or you will do. Just stop it and write and see me the answer. Tell me the answer. One second. Pause karo and tell me the answer. Okay. I write what? Q equals to what? 125 joule. Here W equals to what? Minus P external delta V. P external delta V you have to find out. How to find out the P external delta V? What? P external delta V means V2 minus V1. Delta V minus V2 minus V1. You have to find out. And what is this P external delta V out here? What? P external कितना 1.2 atmosphere into V2 minus V1 कितना है 1 से 0.5 तो मैंने 1.0 minus 0.5. Clear? So it will be what? 0.5 into 1.2, that means 6. Clear? 6. So W equals to 6 मिल गया. 6 ना 0.6 1.6 दोनों है ना 0.6 liter atmosphere. Okay, liter atmosphere. 1.2 into 0.5. Clear? So 0.6 liter atmosphere. And from liter atmosphere you have to convert 1 liter atmosphere means kitna? You have to convert in joule or calorie. So you have to multiply 103.3. You have to multiply. So in this out here, what you have to do? Yes. Then I am doing out here. W equals to हो गया माइनस P एक्सटर्नल डेल्टा V, इसमें हो गया कितना 0.6 लीटर एटमॉस्फेयर. लीटर एटमॉस्फेयर से you have to multiply कितना बोलो 101.3. Okay, this is the joule and its value will be what? Its value will be, this is minus 60, 60 something 60.78 होगा, हो सकता है एज जूल. दिस इज द W. नाउ कम, व्हाट इज द फॉर्मूला? डेल्टा इक्वल्स टू Q plus W out here. So it will be minus, what is the Q? 125. So in this case you have to 125 plus what? That is the minus 60.78. So what is the result? That is the answer. That is the joule. So it more only 64.22 joule. It is the answer. Clear हो रहा है? Clear? समझ गया कि नहीं? Again, I am again telling, it is heat is absorbed, Q is given, but external pressure 1.2 atmosphere is given. So W equals to minus P external delta V. What is delta V? From 0.5 to 1, that is expansion. Pressure exerts and work done and expand from 5 to 1. So that is V2 minus V1, that is P external into delta V. Delta V का मतलब this one. So 0.6 liter atmosphere. So liter atmosphere you have to convert in what? Multiply joule. So you have to multiply with 101.3 joule. That is just minus 60.78 joule. That is the work done. Heat and work. And this is the formula. W equals to delta Q plus W. Q equals to this. W equals to this. And this is the, okay. So change in internal energy equals to ato joule. Clear? Now
इसीलिए समझ रहे हो ना? बस यही है.
So this sounds is important. This type of sounds will come in leaf, joint, HS, all this thing. This type of just समझो the type क्या है? Oh, type क्या है? चलो.
A few moments later.
So now start enthalpy and change of enthalpy. Okay, then what is enthalpy and what is change of enthalpy by enthalpy change? And it will be delta H. Enthalpy, it is a state function and extensive property. State function and extensive property. Remind it, okay? Extensive property. It does not depend upon the path. It depends upon the amount of matter contained in it and the nature of the system, all these things. And it is denoted by H, okay? Denoted by H. And it depends upon, that is the amount of substance, nature and the conditions of temperature, pressure, etc. Okay, that's why it is state function, okay, and extensive property. Clear? So what is the enthalpy? Enthalpy is nothing but in any system that is solid or gaseous हो, all these things हो, इसमें अंदर की इनिशियल भी इसको प्रेशर वॉल्यूम है, इसको वॉल्यूम है, ओके. सो इन दिस केस इसको इंटरनल एनर्जी भी है, ओके. इंटरनल एनर्जी, all these things it contains a system. That is the sum of the internal energy and pressure volume work. Pressure volume work क्या है? That is the pressure volume work. Very important things. Pressure volume work, that means this system I have to create a new pressure volume of the system initially. You have to transfer. Suppose that is heat, enthalpy equals to U plus PV energy. U plus PV energy. Internal energy, this is internal energy and this is PV energy, pressure volume energy. Okay, the sum of this is the enthalpy, and this enthalpy, just like internal energy, absolute value of internal energy and enthalpy cannot be determined. Okay, so in this case we have to find out the change of enthalpy. Change of enthalpy can be changed, can be determined. Delta H can be determined. Okay, but H, enthalpy, just like internal energy, cannot be determined. So what is change of enthalpy? That is delta H. What is delta H? Okay, suppose by enthalpy change इसका नाम है enthalpy change. Enthalpy change, delta H at constant temperature and pressure. Remind it, absolute value of enthalpy cannot be what I told out here. So delta H can be experimentally determined. Suppose change of enthalpy, initial heat of a system is H1 and final H2. So change of enthalpy delta H equals to H2 minus H1 by H initial minus H final. You can write change of enthalpy. This is change of enthalpy. Okay, or you can in a chemical reactions, that is the product and the reactant, A plus B equals to C plus D. What do you know? In that case, the total enthalpy, summation of the enthalpy heat of the product and summation of the reaction. In that case, you can write also delta H equals to, you can write also the you can write summation of what? Summation of heat of the product. Okay, you can write it, heat product minus summation of the HR. Okay, this is the enthalpy of product, enthalpy of reactant, enthalpy of product, enthalpy of reactant. Okay, this is the delta H. Okay, summation of this minus summation of this, enthalpy of product minus enthalpy of reactant. You can read. In this case, if in this case enthalpy of product is greater than enthalpy of reactant, so in that case it will be positive. That is delta H will be, this is greater, it will be positive. Delta will be positive. Positive means heat greater than 0, and it is endothermic reactions. It is endothermic reaction, that is heat is absorbed. Suppose A plus B equals to C plus D plus Q. This is the energy. Okay, and in this case A plus B equals C plus D plus Q. Energy evolved. Okay, that is this is known as endothermic reaction. Clear? Okay, but in case less than summation of H reactant, if this, so it will be, that is delta H will be negative. It is negative. Delta H will be negative in this case. That is, in this case heat will be what? Heat will be what? That is minus. That is exothermic reactions. It will be evolved. Here it will be absorbed. Here it will be evolved. That is negative. That is, in this case A plus B reactant, C plus D minus Q out here. So it is heat. It is, what is this? It is exothermic reaction. Clear? So remind it, though it is the enthalpy of product and enthalpy of react is greater than this positive, it is less than, it will be negative. Okay, next enthalpy is very important thing in this case. Enthalpy change, delta H and delta U, and the relation you can also write. What do you know from the H? What do you know out here? H equals to what? What do you know? U plus, that is the internal energy, plus PV, and we know U plus PV, we know H equals to U plus PV. So both delta H equals to delta U plus delta PV. Okay, delta H equals to delta U delta PV. Delta H equals to delta U, that is, you can write also delta U plus delta V2 minus V1. You can write also delta P2, that is P2 minus V1 minus P2 V2 minus P1 V1. You can write also. Out here delta PV means here you can write also this P2 V2 minus P1 V1. You can write out here. So delta U delta H equals to delta U plus delta P2 V2 minus P1 V1. You can write it at constant volume. At constant volume, delta H volume constant. What do you write? Delta H, you can write delta U plus delta PV. Delta U plus delta PV. That is at constant volume. At constant pressure, it will be P delta V. V delta. And in this case, if you are to change at constant volume means V delta P. When constant volume, the V delta P, at constant pressure, P delta V. That is delta U plus P delta V. That is delta H at constant pressure. At constant pressure, delta H equals to delta U plus P delta V, and at constant volume, delta H equals to delta U plus V delta P. This is very important. Yes. So many numericals will come. These are the very important relations and reactions which will come, and in case of numerical problems, we'll discuss about all these formulas and their numericals in the next video. Okay, thank you. So thank you. Good night. Okay, so be happy and stay happy. Okay, so please share and like my channel. Okay.